Smart. Khakis. Robots are smart. Robots don't wear khakis. Hey San Diego, I'm Ashanti, your host for another exciting episode of FLEETtv. If you watched The Terminator like I did when I was a kid, you might be concerned about robots taking over the world. But have no fear, robots are here to stay and they can be so useful to our everyday lives. Just don't upset them. If you are curious about robotics, I'd like to introduce you to Team Inspiration, a robotics team from right here in San Diego. They've participated in a few of our Genius in the House programs here at the Fleet Science Center, and now these kids, that's right, youth, are going to school you on what is robotics.
Hey Fleetsters, my name's Colin.
My name's Ashiria.
Oh my gosh, what is that?
That looks like a robot.
What's a robot?
A robot's a system of moving components that can take in surroundings and react to it through movement.
Interesting. Do you think my alarm clock could be a robot?
Yes, of course.
We program it with the buttons on top, and it also gives us output and feedback, so yeah, I think that's a robot. But hey, why do this alarm clock, my Lego robot, and your robot look different? Why is that?
Have you ever heard of a thing called requirements?
Requirements. Remind me, what is it?
Requirements are these things that robots must accomplish to achieve their goals.
Interesting. What's the requirements of your robot?
Our robot has to stack these stones way up high to get points in the match and do it under a certain amount of time.
Super interesting. Yeah, we have the same requirement of stacking those stones up way up high. You can sort of see them here. They stack together just like Legos, almost like our Lego robot. But also another set of requirements that we had was to have our robot have super accessible electronics. So you can see here, this is the bottom of the robot. You can see the wheels here. You can lift out this plate and we can have all this access to our electronics. So although our robots manipulate the same game pieces, our robots look very different based off of that requirement of easily accessible electronics. But this robot over here, now this one is just made to be scary. Oh my gosh!
Well, I don't know what his problem was, but can you think about requirements for the robots in your life? What does a clock need to do? What about a doorbell?
Oh my gosh. Oh, that's scary. That's so scary. Oh man, what if we threw your robot in water? Do you think it'd still work in that environment?
I don't know, what do you think?
Maybe we should try it. Just kidding, don't try that at home. Do not throw electronics in water. But we can make it a requirement about our robot having to operate in water and design around that. Then electronics could float in water. But hey, you can catch that on our own YouTube channel at Inspiration11128 at youtube.com. We'll be super excited to go over that and we'll share with you our underwater robot, what those requirements were, and what tasks that robot will accomplish. Thank you guys so much.
Bye.
Bye-bye.
Huge thank you to the Team Inspiration Robotics for being a part of this episode. If you are curious and interested in robotics, find out how you can join a robotics team. Better yet, start your own. It might be a lot of work, but it's going to be a ton of fun. Speaking of fun, what do you call it when a robot eats a sandwich in one chomp? A megabyte. Next up, I'm gonna send you to one of our Fleetsters in the field, Steve, who's gonna show you how you can make your very own smart water pump at home.
Hi, I'm Steve and I'm an electrical engineer. I like using technology and I like helping my friends out with their electronics project. Today I'm going to talk about a project that I'm helping my friend Mike out with. Mike has a cabin by a lake and there's a pump that he uses to fill up his water tank from the lake.
This is the uphill tank water pump. the intake line coming from the lake. And over here is the overflow line from the tank. You can see there's a little bit of water coming out of the overflow line because I just pressed the tank full. And over here is what they call the pump house generator shed with a generator in it with AC lines going to the house, which is up above there.
And he wants to be able to turn on and off the pump when he's at his house in the city. So how do we do that? First, we're going to need something that's going to allow us to turn on and off the pump electronically. And for that, we're going to use an Arduino, which is a small microcontroller board that you can buy. They're inexpensive. Since I don't have the pump at my home, I'm going to use an LED circuit to simulate the pump and make sure that I can turn it on and off. Then when we install this Arduino at his cabin, we'll replace it with the correct circuit to drive the pump. Once we can drive the LED that simulates our pump, we need to connect it to the internet. To do that, we're going to need a second board, which is called a shield, and that plugs in on top of the Arduino. We're going to use an Ethernet shield, and that's going to let us connect our Arduino to the network at Mike's cabin. So an Arduino is a small microcontroller, and while it can connect to your local internet easily enough, it's not very good at making a secure connection to the outside world. So to do that, we're going to use a second device, which is a Raspberry Pi. It's more like a real computer, and with this, we'll be able to make a secure connection outside of Mike's cabin so he can access it from anywhere, from his house, from his phone. And this is going to make it easy for us to do that. Using a service like Dataplicity, Mike can easily access his Raspberry Pi from his cell phone or his home computer. So there you have it. So for maybe about $30 for an Arduino plus a shield, and then another $10 for a Raspberry Pi, Mike can connect his water pump to the internet and control it from anywhere in the world. It's fun to use technology to solve problems, and today it's easy to do with all these inexpensive devices on the market. I hope you found this interesting, and thanks for watching.
Thanks for that demonstration of automation, Steve. Here's your challenge, San Diego. What can you automate at home? Whatever you decide, make sure you share it with us. We always love to see how you are using STEM in your everyday life. Now, we hope you loved this episode, and if you did, you know what to do. Share us with your family, share us with your friends, like us on social, and of course, wave goodbye with a finger.